So here we go with the fourth part of what I was going to try and present today. The last video we just had finished talking about quantum numbers, and we did kind of a shallow, short interpretation of them, but they're not super complicated. They just have a pattern that they follow. So in the first energy level, you have just one L value, so it's an S sublevel. In the second energy level, you have two L values, so you got the S and the P. Third energy level, you got the SPD, three values of L. And the number of beds in like the sunny room or the pink room or the dark room, if you remember that kind of terminology from year one in chemistry, the number of the beds went up by 2 per sublevel. So the sunny room had 1 bed, the pink room has 3 beds, the dark room had 5 beds, the F room will have 7 beds because it'll be -3, -2, -1, 0, 1, 2, 3, so there'll be 7 values. So now we're going to talk about filling order real quick, and we'll be done with the little stuff that you need to be able to do your homework. So filling order is the sequence that the electrons fill in. I'm going to start with the elementary school version, and we'll move to the smart kid version in a minute. So in the first energy level, you've got the S sublevel. In the second energy level, you've got the S sublevel and the P sublevel. All right, in the third energy level, you have the S sublevel, the P sublevel, and the D sublevel. Fourth energy level, you got the S, you got the P, you got the D, you got the F. And you notice that every time we go up to a higher energy level, we are adding a sublevel. So in the first energy level only had the S. The second energy level, the second ring around the nucleus has the S and the P. The third ring, the S, P, and the D. And the fourth ring, the S, P, the D, and the F. So that means the fifth ring is going to have an S and a P and a D and an F, and then we got to have another one, and they go alphabetical there. It's a G. Then the 6S, 6P, 6D, 6F, 6G, 6H. Now, nothing is large enough to have anything beyond a 5F in its ground state, so the whole thing stops here. But unless the atom's excited, so then you got 7D and 7F and GHI, but we'll just stop right there. All right, now the sequence that they fill in is a little bit wacky. So the 1S fills in first, and then the 2S fills in. And this is not surprising because they just go in order. 2P, 3S, 3P, and then the overlap begins to happen. So after 4S, 3D begins, and then 4P, and then 5S. So they get real convoluted up in there. And after 5S, we go down to 4D and 5P and 6S. And after 6S is 4F. So you come here, 4F, 5D, 6P, 7S. And after 7S, 5F, 6D, 7P, like that. Well, that seems kind of complicated, but really, it's not. So this is a periodic table. Now, you know the S only has 2 electrons per sublevel, because it only had 1 bed. The P had 3 beds, 6 electrons. The D has 5 beds, 10 electrons. The F, you see a pattern? 18, 22. All right, here's a periodic table. Now, I have some numbers written here. I just was writing the valence electrons, which we already know about, so I was doing this in general chem, and I had this one laying here, so I just popped it out. So anyway, this is the S region on a periodic table right here, because it's too wide. This is the P region, 1, 2, 3, 4, 5, 6. This is the D region. There's 10 wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means the D sublevel is filling in as we cross these elements. And then this is the F region. Now you know that on a periodic table, this doesn't look like your periodic table because these guys are down here at the bottom of your periodic table. All right? All right, so now let's get a real periodic table. And here is how you're going to know the filling order. This is the Smart Kit version. So we know that we start with 1S, and then we go to 2S, because over here, remember, helium should be over here. But chemically, it fits better over on the other side, and so we put it over there. All right, then 2s, then 2p, then 3s, then 3p. See how it says even on this little table? It's on the front page of my website. 3p, then you got 4s. I should maybe give Science Geek credit for this. 3d, 4p, 5s, 4d, 5p, and after 5p we go to 6s right here. Then there's this little sign right here that comes down. It says, oh, go down here and go look for 4f. So instead of putting the f's down here up here in the table where they really fit, we put them down here because it just saves space. Okay, after 4f you have to come back up here and start 5d, and then 6p, then 7s, then the same thing for 5f, then 6d, then 7p, and there you have your filling order. So if I was going to write the electron configuration for an element, say lead, I'll just do lead as an example, I'll write it in this little space right here. I'd write the 1s holds 2 electrons. Then the 2s holds 2 electrons. Then the 2p, how many does it hold? 1, 2, 3, 4, 5, 6. 6 electrons. I'm doing lead because I know some of you guys are into heavy metal. So 2p, 6. And then 3s, it holds 2 electrons. And then 3p, 6. And then we have 4s with 2. Then 3d with 10. I'm not up to lead yet. I got a ways to go. So just keep going. Then 4p with 6. And then 5s with 2. Then 4d with 10, and 5p with 6, 6s with 2, and then we have to go down to this 4f, remember, so 4f, it has 14 because there's 7 beds in the fine room, and then after 4f we go to 6p, but oh, there sits lead right there, and that's the second one in the 6p region, so we just put a 2 there to show that it has 2 electrons in its 6p sublevel, and that's what we call in chemistry an electron configuration following the Aufbau principle, AUF-BAU. It is just a filling order of electrons. Not everything does exactly what it's supposed to do, but those elements in the S and the P blocks do exactly what they're supposed to do. All right, so if you're doing a simpler element, like say maybe oxygen, that I talked about earlier, it has 8 electrons. 1s has 2, 2s has 2, and then we're over to the 2p. It has 4. So I'm hoping that that's enough background you'll be able to answer the electron configuration questions. Might mention, we've already talked about valence electrons, and you noticed that on this periodic table I used in a general class the other day. But actually this was the advanced class. So these valence electrons here, there's 3 in this column, 4 in that column, 5 in that column. So if you look where oxygen is right here, it's got 6 valence electrons. They're right here. So the number of valence electrons includes the S and the P sublevel, but it will not generally include the D sublevel. It never will in a normal situation. So S's and P's make the outer shell. All right, I think I'll stop that and post it. It's getting to be 5 o'clock on Friday, and I have a tenderloin at home, a pork tenderloin to eat. So I'll see you on Tuesday. Hope this helps.